Okay, for question 4, it is a hybrid question that combines content from pressure and also content from moment. In fact, this is a homework question that is in your worksheet. I think if you look uh, if you look up the worksheets in your moment chapter, this is one of the question in your homework. So if you are not able to do this question, it is kind of disappointing. It also means that when you prepare for your exam, you didn't look through or at least redo the worksheets that you have. Okay, so let me break it down for you. So down here you are given a very simple straightforward question, find f, and you will realize that there is the hint given here. If you see pivot and you are supposed to find f or distance, and if you see pivot, it is basically a glaring hint to you that you have to use moment. So if you look at so how do you approach this kind of question? Once you see the pivot, the next thing you have to identify is what is the body that you are playing around with. So if you look at the diagram, I like to sketch another diagram beside it whereby it is isolated from all the distractor. So down here you have this thing. So down here you have this particular thing that looks like this, right? This is this thing. I am sketching it out, right? So I'm seeing this body. Obviously this is your pivot that is already given. So down here there is a force that is being applied to the braking pedal. So this is the force. But then there is this thing. 42 Newton is applied onto piston A. So onto piston A meaning what? Meaning can you see here, this is your piston A. So this 42 Newton, it is not applied to the beam, but applied to the piston. So it means that when I want to isolate my object, this piston is actually a separate piece of thing, right? So there's this, and then there's this piston here, whereby there's a force acting on this piston, which is 42 Newton. So this piston is actually a separate object. In another word, if you remember your Newton third law, this 42 Newton is actually the force that is exerted by the lever on the piston, right? So in another word, this force is actually LP, right, by the lever on the piston. But since I'm analyzing the moment for this particular lever, the green one, this lever over here, I have to find the force that is acting on the lever. For example, this force F is being applied on the pedal, which is the lever lah, right? So in another word, I need to go and find the force that is by the piston and on the lever, right? So in another word, I need to find FPL. And as you can see here now quite clearly that your FPL and your FLP are action reaction pair. So by action reaction pair, I will know that, oh, that means I will have an exact 42 Newton acting over here. So once I see this, I can now erase this distractor, and I can see that, oh, now I see it, right? On this lever, there are two forces acting on it. One is the F force over here, the other is 42 Newton. I have a pivot over here, and I can see that this F will give me a anti-clockwise moment, and then this F over here will give me a clockwise moment because my P is over here, right? So I will know that, oh, in this case, then that means I have, anti-clockwise moment equals to clockwise moment. So the other thing that I need to pay attention to is what is the distance. So for this particular F, the perpendicular distance will be given by this law, right? This is my perpendicular distance, correct? So I know this D. Then after that, I need to know this D, which is given by this, right? So using the moment formula, F times D, and then I take this F times this D, I equate the two of them together, I should be able to find my answer. And your answer should be to 2SF. You should get 10.5. but after you round it up to 2SF, it will be 11. Okay, then for part B, again, it is your homework question. So what you need to know is that the system expression, okay, so I keep emphasizing this system expression. So if you look at the this part, this hydraulic jack or hydraulic braking system, basically what you have is that you will have piston A and piston B, and piston A and B are linked together by this fluid that is inside. So meaning that whatever pressure that you exert at piston A will be transferred to the pressure acting on piston B. So in this case, basically what you need to know is that the pressure exerted by piston A will be equals to the pressure by piston A will be the same, will be transmitted to the pressure on piston B. So once you have that, pressure is given by F over A. Here is also F over A, but this F will be the F acting on A. This F will be the F acting on B. Similarly, for the area will be area of A, and then down here will be the area for B. So once you have that, it is then quite straightforward. But I introduced a twist. I didn't give you the exact value for the different area, but instead I give you a ratio. So you need to turn this statement into a math expression. So area of A is to area of B is equals to 1:8. So mathematically, you will have something like this. Right, so it means that your area of B is 8 times the area of A, and it makes sense, right, from the diagram that area of B is much larger than area of A. That's why 8 times of area of A. So if you look at the diagram here, it makes sense. So that's how I check my math. So once I know that, then it will be just a matter of substitution. So here, FA over AA, FB over AB. Then I already know my FA, right? My FA over here will be this. This is the force acting on piston A. So I will simplify this to this. This is my unknown. Then I just play around. I take this 42 out. Then I bring this A like that. And this fraction I can see from here, right? So this is AA over AB is 1/8. So AB over AA will be this. So that's how you get your answer, which is 340